My name is Joe Nuth. I'm a senior scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. That's just outside Washington, D.C. The seminar that I will be giving is basically talking about a complex carbon cycle. Effectively, the carbon and silicate grains in the interstellar medium are very intimately mixed. There are a number of models, and all of them have carbon and silicates pretty much together. They get into the solar nebula, they get hot. The materials in the inner nebula get very hot, and the carbon reacts with the silicates basically to smelt them, giving carbon monoxide and metals as the result. The next step in that is that the increased carbon monoxide reacts with hydrogen on the surfaces of these grains to make different carbons, basically through a process like the Fischer-Tropsch process, but much messier in that respect. You get a whole range of carbonaceous materials, basically from alkanes to the aliphatics. You get split chains, you get aromatics. There are a wide variety of both solid carbons that stay on the surface of grains, as well as carbonaceous volatile carbonaceous molecules that go back into the gas phase. The interesting part also is that the solid carbonaceous material that deposits on grains in many instances is a better catalyst than the actual metals themselves that they formed on. So there then is a dichotomy in the carbonaceous contributions that you get to planetary systems. The outer solar system materials never got that hot and will contain all of the interesting isotopic differences that come with formation in cold environments, while the inner solar system will have none of those isotopic anomalies and will be basically a different set of materials produced in many ways like the Fischer-Tropsch reactions, but as I said, a little more complex. So there is then the dichotomy between the outer and the inner solar system carbonaceous material, and there is the history that should basically give you an increase in carbon monoxide in the inner solar system, and that increase in carbon monoxide promotes the reaction of the CO hydrogen on the surfaces of the grains to make the new carbonaceous materials. And that's basically the cycle I'll be talking about.